Hello there, Year 10. Pythagoras' theorem we're going to continue with today. A little bit of a starter here. Don't forget Pythagoras' theorem. A squared plus b squared equals c squared. Where a and b are the short sides of a right angle triangle and c is the long side. What's the long side called? Hypotenuse. Short side squared plus the short side squared gives you the long side squared. So for this example, you'd have to do 6 squared added to 4 squared, and that would equal long side squared. So if you want to copy down quickly, sketch those diagrams down, or freeze the frame so you can have a go at those. Use that formula, a squared plus b squared equals c squared. Don't forget, if you know the long side and you're trying to find a short side, you've just got to rearrange that formula a little bit. So if you pause your video and then come back and I'll go through the solutions to you. Okay, solutions. 6 squared plus 4 squared will give you the solution to this one. Now this one, we've got a short side that we don't know. We know a long side. So our short side squared is the long side squared, so it's 81. Take away the short side squared, so it's 25. That will give you b squared. You've then got to work out the value of b. Long side squared, take away the short side squared, gives you the other short side squared. So we've got to do 7.3 squared. Take away 5.5 squared, and that gives us our solution. This one's back to, we've got 2 short sides there, so 7.1 squared added to 5.2 squared gives us our long side, our hypotenuse squared. For these two, they're isosceles triangles. They're not right angle triangles, but they are isosceles triangles. What we do is this, ladies and gents, we put a line down the middle there. That now means we have got a right angle triangle here. We know this side is 12. We know this side is now 5 centimetres, isn't it? So that means that our long side there that we don't know is 12 squared. Oh, hold on. No, yeah, we don't know our long side there. So we do now this side here, which is 12 squared, 144, plus 5 squared, which is 25. That's 169. So our actual side there is going to be 13. Similarly here, we know that's 15. We don't know this little short side here. We know that's 17 there. That's our right angle triangle. So this time we've got to do 17 squared, take away 15 squared, and that will give us our short side. So our actual solutions, if we go through to them, 7.2, 7.5, 4.8, 8.8, 13 and 8. They're our solutions to those examples that I've given you in your starter. Right, okay. Do you want to have a go at this? Giving away the answer there, haven't I? Write down the squared numbers from 2 to 20. If you want to do that, have a go at it, just to practice. Don't use calculators, see how many of them you can remember. Pause while you do that. Go on, and I'll give you the answers. Square numbers from 2 to 20. There you go, there's your squared numbers from 2 to 20. Some of these ones are more difficult to remember. The more of these you can remember, the easier you're going to find questions in the future. Just let you absorb those answers there. Might have to freeze frame. Good practice. As many of those as you can remember, always going to help you. Right, Pythagoras' theorem, we've talked about it already this morning. A squared plus b squared equals c squared. That is the basic formula. Short side squared plus the other short side squared equals the long side squared. If we want to find a short side, we just rearrange that formula so we get a short side squared equals the hypotenuse squared, take away the other short side squared, and similarly. So it's just a little bit of rearranging there. That is Pythagoras' theorem. A couple of examples. Calculate, and this is a worded question, so this is the ones you want to try and get used to doing because this is what's going to turn up in an exam. Calculate the area of an isosceles triangle with sides 5 centimetres, 5 centimetres and 6 centimetres. Now we did an example like this in the starter, so it's just to reiterate that to you. You've got a 5 centimetre side, you've got another 5 centimetre side, and you've got a 6 centimetre side. Isosceles triangle, 5 centimetres, 5 centimetres, 6 centimetres along the bottom. Not a right angle triangle, it's asking you for the area of that isosceles triangle. So, similar to the way we worked in the starter, divide the isosceles triangle into two, just draw a line from the apex, the pointy bit, down to the baseline. That forms a right angle. We've now got a right angle triangle. We've got a length of 5 here, we know that. We know that's going to be 3 centimetres there. That means we can then work out the length of this side. So it's a 5 centimetre length, 5 centimetre length, 6 centimetres. That is 3 centimetres there. Know the long side. So 5 squared, take away a short side, 3 squared, and that equals your unknown short side. So a squared equals 25, take away 9, that equals 16. So if a squared equals 16, what does a equal? A equals 4. What does the question ask us to do? It asks us to find the area of that triangle. We've now got the height of the triangle, which is 4, and we've got the base of the triangle, which is 6. So the area, half base times height, half times the base times the height, 12 centimetres squared. Okay? We didn't know the height of this triangle. We've used Pythagoras to find the height of the triangle. That's the first part. Once we've found the height of the triangle, we can find the area because we know the base is 6 centimetres. We now know the height is 4 centimetres. Area of the triangle is a half times the base times the height. Half times 6 times 4 is 12 centimetres squared. A worded type question. Another worded type question. Chris runs 12 kilometres east, followed by 5 kilometres south, and finally runs back to his start point. How far has he run in total? He's gone 12 centimetres east, 12 kilometres east, he's gone 5 kilometres south, and gone back to the start point. Tip, draw a diagram. So starting from here, 12 kilometres east. So that's 12 kilometres we've run east. He's then run 5 kilometres south, 5 kilometres. And he then runs back to where he started. Okay, how far has he run in total? 12 plus 5, but how far is this? That is a right angle because we've gone east and then south. We've now got a right angle triangle. We need to find this. It's a long side, so c squared equals short side squared, so 12 squared plus the other short side squared, 5 squared, so it's 144 plus 25, so that equals 169, but that c squared is 129, so c equals 13 kilometres. So we now know that that is 13. The question asks, how far has he run in total? 12 plus 5 is 17. 17 plus 13 is 30 kilometres. So he's run 30 kilometres in total. Okay? Last example, this is an exam type question. Shows a rectangle ABCD. So we've got a rectangle ABCD. CD is 42 centimetres. The triangle ADE, so we've got a triangle stuck on the end here, says AE equals 10.5 and DE is 14. Calculate the length of AC. So they want us to find the length of that diagonal line there. Now we've got a nice little right angle triangle here with the 42 centimetres at the base, but we don't know that length. So try this for yourself first. We can use this right angle triangle here, where we've got the two short lengths here, to find that length AD. Once we've found AD, we can then use that length there and that length there in a right angle triangle to find AC, which is what the question's asking us to do. So have a go at that for yourselves first, and then we'll go through the solution. Okay, solution to this question. AD. We know that this is 10.5. We know that this is 14. So 10.5 squared plus 14 squared would be AD squared. 306.25. You can do that on your calculator. AD does equal 7.5. But AC squared, so this diagonal that the question's asking us to find, is going to be AD squared, which we've just calculated. Funny enough, AD squared, 306.25, plus DC squared, the 42 squared. So that gives us AC squared. If we add those two together, find the square root of it, we get 45.5 centimetres for our diagonal. Is that a reasonable length when that's 42 centimetres, making that 45 centimetres, 45.5 centimetres? Yeah, it's not an unreasonable type answer. Okay? And it brings out an interesting point here. We've calculated AD squared. Now I've shown you that the square root of AD squared is AD, which is 7.5, but actually, because we're still working with right angle triangles afterwards, Pythagoras' theorem, we didn't actually have to work that out. Doesn't matter that we have, but AD squared plus DC squared is 306.25 plus 1,764. Square root of that result gives us 45.5 centimetres for our answer. So we've done three different examples there. An isosceles triangle where we've been asked to calculate the area. So we've used Pythagoras to find the height, and then we've been able to find the area. We've then done an example of a worded question. Draw a little diagram to show ourselves what's happening and help us understand it. And we've got our solution out. And don't forget to actually answer the question. It's not just asking you to find that length. That length enables you to actually answer the question. How far is you run in total? 12 plus 5 plus 13. Don't forget to answer the question. And the last example, it's an exam type question. It's saying at level 7, but it will be something you're expected to do really now at level 5. This is an old example. Use one right angle triangle to find a side. Once you've found that side, use that to then find your ultimate solution, as I've done for you there. Okay, hopefully that's been useful to you. Thank you for your attention and good luck with the examples that you're going to be working on.